Now we're looking at how the physical structure of polymers determine properties. Notice that it's a physical structure, no actual chemical reaction or physical bond involved. So how does this determine properties? A very short one, the physical structure or polymer structure refers to the packing order, just how the chains are packed. And there are only two ways that can happen. They can be packed in a crystalline manner, in an ordered regular fashion, or in an amorphous manner, randomly like spaghetti. That gives different properties as well. Looking at them in a bit more detail. So if you have the amorphous kind of arrangement, the spaghetti type, it's irregular arrangement, loosely packed. The properties that you get out of that physical structure would be the transparent kind of polymers. They will be flexible, they will be very light, less dense. So some example, ABS, polycarbonate, polystyrene. And then if you have a regular, closely packed version, the crystalline physical structure, those will be the type of polymers that are opaque as opposed to being transparent. They are a bit harder and they are dense. Examples, nylon, PET, and acetal. So two types of physical arrangement, amorphous or crystalline, giving you different properties. So to put it all together, polymers are made up of long chains. How do you get different properties from polymers? They can either be cross-linking between the chains or no cross-linking. If there's cross-linking, they are either thermosets or elastomers. If there's no cross-linking, properties are different based on the arrangement of these chains, which are not cross-linked. And then the arrangement can either be the pecking order, crystalline, amorphous, or something in between, semi-crystalline. In terms of the everyday life, the thermosets, thermoplastics, in fact, sorry, they are the ones that make up 90% of the market out there. These are the typical examples. So you're likely to be working with thermoplastics more than thermosets. Thermosets make up 10% of the market. And then these are the examples of thermosets. So that's how you get different properties of polymers and how you classify them. Just a few examples before we enter this set of lectures. The common one, PET, that you use to make bottles, drinking bottles. So this application, they are suitable for this application because of these properties, which you do not need to remember of by heart, but just to show you the suitability of properties based on the products that you want to make. So because PET is known to be very light, it can withstand high tensile stresses, it's hard and rigid and strong, dimensionally stable, it absorbs very little water. That's why you would use it for that. Good chemical resistance, it needs to resist chemicals. Medium resistance to UV, so they can tolerate being outdoors to some extent. They are most commonly recycled polymers. They form polymer recycling number 1, PET. Generally, you can see these numbers of these products, and so on. Then high density polyethylene. This is the type of polymer that you would find usually in bottles. And then the process that commonly they use would be injection molding or blow molding. You can also find it in films, but for the most part, they make bottles out of high density polyethylene. Why is it suitable for this type of applications? Because it is excellent for any food related products. It machines very easily, so you can drill into it. Good chemical resistance again, because this can be used for something that you eat, so you don't want something that is weak in terms of resisting chemicals. It has good impact resistance as well. If it falls, it doesn't break because it has high impact resistance. Lightweight, poor UV tolerant. So high density polyethylene cannot be left outside and retain its properties for a long time. So that's why it has poor UV tolerance. So if you making a product that's going to be applied outdoors, you would definitely not consider high density polyethylene and many other properties. So they are recycling number 2. Polyvinyl chloride, PVC. We commonly see it in plumbing, usually making tubes, you can make cables, flooring, and it's suitable for these applications because, as we saw, the amorphous kind of arrangement makes the polymer light. So you want this type of polymer to be very light, so it can resist UV, and it's excellent chemical resistance. You wouldn't want them to degrade these pipes when they are underground, so you need something that is excellent in terms of resisting chemicals. It is easily machinable as well. You will notice that there are similarities in terms of properties, but there are those that are more suitable than the other in terms of applications. So the whole point of this being properties make polymers suitable for a specific type of application. Polymer recycling number 3. The low density polyethylene. This is the direct opposite of high density polyethylene. This one, low density, meaning it's light. Né? That's why it will make, usually they use it for films and lightweight bottles. And then it's compared to high density polyethylene here in terms of properties. It's suitable because of these properties. Then polypropylene, the Tupperware type of application. So again, suitability in terms of products that you can make out of it because of this property. And then this one forms, it's part of recycling number 5. Polystyrene, again, lightness, irregular arrangement making this type of polymer light. As you can imagine, this type of applications or products, these are very light, polystyrene, because of these properties as well. They are flammable, excellent thermal insulators. You can use them for insulation as well. So they are used in fridge linings as well. So because of the properties, they are suitable for a specific type of application. Recycling number 6. Acrylic. We are familiar with acrylic. Again, very rigid, suitable for these applications because of these properties. Brittle type of polymers. Recycling number 7, that one. ABS, acrylobutadiene styrene, used to make hot hats or Lego. Again, suitable because of this set of properties. That's the end of properties and suitability in terms of application, which is what you guys generally have to understand about polymers. And you start off with knowing the type of application that you're looking into when you make a product, and then you can choose the appropriate polymers. I will not go into the polymer processing because you guys are still busy with the processing techniques. So to give everyone a chance to tackle the assignment, then we will continue, I think maybe next time. That's the end of polymers. Thanks, guys. Hope that helps.